Okay. So for this Lagrange interpolation problem, uh, we're kind of going over the basics of Lagrange interpolation. So we want a polynomial of degree 2 over a GF of 7. And we have some of points here. There's 1 point, 2 points, and 3 points where we specify the inputs and outputs, right? And we want to find out what is the polynomial that satisfies all of this stuff, right? And there's a pretty neat trick that we use for working in the Galois fields and stuff. So what we can do is we can identify three sub-polynomials that are kind of like atoms, right? And the easiest way to think about this is that okay, so how basically if the points that we have are 1, 2, and 3, meaning those are the inputs, like over here, 1, 2, and 3. Um, what I want for polynomial number 1, if you give me a 1, I'll give you a 1. Anything else, you give me a 0, right? This is how it works. And for polynomial number 2, if you give me a 2, I'll give you a 1, but anything else, I'll give you a 0. And for polynomial 3, if you give me a 1 or a 2, I want a 0, right? But if I give you a 3, give me a 1. That's kind of what this graphic right here is showing us. Where P1 is the first polynomial, right? So you have the 1, 0, 0 right there, and then 0, 1, 0, and 0, 0, 1. That's what this is kind of saying. Pretty much in general, for polynomial I, you'd be like having zeros everywhere, except for the ith position, you would have a 1 and then 0 everywhere else. Um, and so this is a pretty nifty way to like break down these bigger polynomials into like smaller. I like to think of it as like atoms, I guess, the equivalent of atoms for polynomials. Um, but yeah, so how can we express P, which is this thing right here? P is like characterized by these 3 points that we know, right? 1, 2, 2, 1, 3, 4, right? And then in terms of P1, P2, and P3. Now here's the thing. What I can do is, in order to specify this particular point, I can say um 2P1, right? So now if I have 2P1, I guess of X, right? But I'll just leave that part out. 2P1, what that means is that if I give you a 1, this will, like, if X is 1, this will end up giving me 2. Otherwise, it's 0, right? So we have specified for the point that we want to specify for, while also having nothing to say about the other points. That's kind of how I like to think about it. And we can add P2, right? So now if I put in a 2 here, this one will become a 1. Everything else will become a 0. And I'm left with just 1, right? I guess a 1P2, right? And then plus 4P3. So if you think about it, if I put in a 3, this will become 4, right? 4 times 1. Everything else gets crossed out, right? So that's the beauty of this. If you put in any of these numbers, 1, 2, or 3, you'll get back whatever the other number was, because we made that the particular coefficient for that, polynomial, for that sub-polynomial, right? Um, and you can work this out to see that these 3 points are satisfied, right? Now, part B asks us to actually find a polynomial that gives us this kind of representation, right? For example, for P1, right? Um, so to start off with, show that P1 must have the form C times x minus 2 times x minus 3. So this is pretty easily done through like just reasoning it, right? We want P1 if we put in a 1, we want it to give a 1. But we're not focused on that right now. Let's focus on the other ones. Let's focus on if you put a 2. If you put a 2, we want to get a 0. If you put a 3, we want to get a 0. For everything else other than a 1, we want to get a 0. That means that this polynomial must have an x minus 2 in it, like a factor of x minus 2, right? And it also must have a factor of x minus 3. So it's like if I put in a 2 or I put in a 3, P1 will become 0, right? And then we need it to have some kind of constant over here because P1 is like degree 2, right? As per this, right? P1 is degree 2. So this is already degree 2. And so, the most general form of this is we just multiply a constant, and that still satisfies, like if we put a 2 or a 3, this will become 0, right? Now, what is the value of C, right? What is the value of C? So what we want to do is now we take into account that if you put in a 1, you'll get back a 1, right? So what I want, right, is that if I put in 1, I put in 1 times 1 minus 2, 1 minus 3, right? I just substituted x equals 1. Then I should get 1, right? Now, what I can do is I can just say C is equal to 1 minus 2 times 1 minus 3, like the reciprocal of that, right? I'm just rearranging this over here. And so if I were to write this thing out again, what is P1? P1 of x, what is that? That is the x minus 2 and x minus 3 thing, x minus 3 divided by 1 minus 2 and 1 minus 3, like that. And by the way, I just want to clarify that when I say divided by, right, I really want to express that this is not division. Like when I do 1 divided by 2, this is not the same. This is not the same as 0.5. Okay? 1 divided by 2 means you take 1 and you multiply it by the inverse of 2, right? So, for example, in mod 5, if I do mod 5, then the inverse of 2 is 3 because 3 times 2 is 6, which is 1 mod 5. So this would be 1 times 3, which is 3. So it's very important that you don't like divide accidentally by this number. You instead find the inverse of that number. Okay. It turns out that so this is -1, right? And this is -2, right? We can actually just multiply these and actually take the inverse of that, right? So there are two things we can do. One thing we could do is we could find the inverse of this thing, multiply it by the inverse, right? Find the inverse of this thing, multiply by the inverse. But that's actually the same thing as multiplying these two things and then taking the inverse. It's you could do it either way. You could verify for yourself that that's true. So this, if you multiply them out, it's 2, right? And I want to find basically, we're actually working on GF of 7, right? Over here, GF of 7. So we want to find the inverse of 2 mod 7, okay? 2 times what is equal to 1 more than a multiple of 7? Well, I know that, for 8 is 1 greater than a multiple of 7, and it's also a multiple of 2, so 2 times 4 is equal to 1 mod 7. So what I can do is I can say that 4 is actually the inverse of 2 mod 7, right? Since 4 is the inverse of 2, because they multiply out to get 1, I can actually write this as 4 times x minus 2 times x minus 3. And that is the final form of P1 of x. Okay. Now find P of P2 and P3 the same way. So basically what we want for P2 is some constant times x minus 1 times x minus 3. Because if we feed in a 1 or a 3, it should become 0. And it should be, just 1. If I feed in a 2, it should give me a 1, right? So I need to find out, like, what do I put in for C? And it turns out it's like the same thing, right? X minus 1 times x minus 3. And I can actually just divide that by, and you can confirm this is the same way that we did it in the last one right here, right? We just did the same thing where we just plugged in 1 for x. That's like that's what the denominator actually ends up being, right? So we just plug in this case, instead of 1, we plug in a 2 because 2 is our x. So 2 minus 1 times 2 minus 3. And it's not actually divided by, it's multiplying by the inverse, right? So this 2 minus 1, so 2 minus 1 is -1. 2 minus 3 is -1. Multiply them both out, you get +1. Sorry, that's that's my mistake. This is 1, +1, +1. And then this one is -1. You multiply them out, you get -1. The inverse of -1 is always actually -1 because -1 multiplied by -1 is equal to 1, regardless of what the modulo is. So that's a neat trick that I like to use. And a concrete example of this is that, for example, if you were doing 6 squared mod 7, right? 6 is actually equal to -1 mod 7. So -1 squared is equal to 1. But you can confirm that because 6 squared is 36, which is 1 greater than a multiple of 7, which is 35. So that's also, it's 1, right? So we confirm that that is the case. Yeah, so we can actually just write this as negative x minus 1 times x minus 3. And if we didn't want this negative sign out here, we have to remember that -1, since that's the same as 6 mod 7, we could actually replace this with a 6, and that would have been the same thing. So this is also equal to 6 times x minus 1 times x minus 3. This is also the same thing. So I'm going to circle that, and we have like the other one circled on the other side. Let's find P3. So P3 over here. Now that if I put in a 1 or I put in a 2, those will both get mapped to a 0, right? That's like the rule of this, and 3 gets mapped to a 1. Now over here, for these first two, right? That means that this is of the form C times x minus 1 times x minus 2, right? Okay, that's the same as what we've done previously as well. And remember that C, in order to find out that C, we just x minus 1, x minus 2, and we substitute in 3 over here, right? So with 3 minus 1 times 3 minus 2, right? And that's the same thing that we did in the first way and the second way. Okay, so now we have x minus 1, x minus 2, 3 minus 1, 3 minus 2. This thing is 2. This thing is 1. And we multiply that out, we get 2. So we want to divide by 2, which is actually the same as multiplying by the inverse of 2. So what is the inverse of 2 mod 7? It's 4. Actually, we already found that out here, right? 4 is the number that you multiply 2 by in order to get 1. So we multiply this by 4. And then, yeah, this is 4. x1 minus 1 times x minus 2. And then all you do to find p is, so let me box this up. All you do to find p is you just multiply this out, add it to this, multiply it out, and add it to this and multiply it out. And what you should get, let me just check real quick. Yeah, so yeah. So you should get oh, by the way, so this is P2, this is P3, and this is P1, right? The thing is, we need to also multiply P1. Remember, we need to multiply P1 by 2, right? And remember, that's the same as if we do 2P1, we have this 2, and we have this 4 over here, right? 2 times 4 is 8, but mod 7, that's 1. So we can just have this x minus 2 times x minus 3. So we get x minus 2 times x minus 3. That's the P1 part of it. Actually, it's not just P1, it's 4P1. Oh, sorry, 2P1, which was what we wrote initially. And then we want just one P2, right? So we want this P2 right here plus 6 times x minus 1 times x minus 3. And then we want plus, what is the other coefficient? It was 4, right? 4p3. So this is, we want to multiply this thing by 4. 4 times this 4 gives us 16, but mod 7, that is 16. Yeah, mod 7, that's 2. Yeah. So we just get a 2 times x minus 1 times x minus 2. Yeah, and I think this should be the answer or equivalent, basically, right? Any negatives, if you get like, let's say you get negative 4x, right? That's the same as positive 3x because you can just add a multiple of like plus 7x because this is equal to 0, mod 7, right? But yeah.